Solved examples in analysis of control systems in a state space. Problem number 1. Consider the system described by y triple dot plus 3y double dot plus 2y dot equals to u. Derive a state space representation of the system. We take a copy from this equation. Firstly, we rearrange the equations because there is a deleted term with coefficient 0 plus 0y. As we observe, this equation is a third order differential equation in which the forcing function doesn't involve derivative terms, the input function only without derivative terms. So, firstly, we define the state variables. The first step is to define the state variables. There are 3 state variables because this equation, a third order differential equation, x1 equals to y, x2 equals to y double dot, y dot, and x3 equals to y double dot. This is the state space variables, 3 state variables, x1, x2, x3, because we deal with a third order differential equations. The second step in the solution is to define the first derivative of the state variables, differentiate x1, x2, x3 to obtain the first derivative. x1 dot equals to y dot, x2 dot equals to y double dot, x3 dot equals to y triple dot. x1 dot equals to y dot, which equals x2, x2 dot which equals y double dot equals x3, x3 dot which equals y triple dot can be found from the original differential equations, minus 3 y double dot minus 2 y dot plus u. We find in the second step the first derivative of the state variables x1 dot, x2 dot, x3 dot, and x3 dot can be found from the original differential equations in a function of y double dot and y dot. We substitute x1 dot and x2 dot in this equation. In this case, x3 dot equals to minus 3 x3 minus 2 x2 plus u. This equation is considered the state equation. The output equation can be found as follows: y equals to x1 in this step we obtain the state equation and the output equation. The last step is considered the state space model of the state variables x1 dot, x2 dot, x3 dot. The derivative of the state variables x1 dot, x2 dot, x3 dot equals to the state equations multiplied by the state variables x1, x2, x3. x1 dot is a function only in x2, so 0, 1, x2, 0, x3. x2 dot is a function only in x3, so 0, 0, 1, x3. x3 dot, which is considered y triple dot, is a function of x2, x3, and u, so 0, x1, minus 2, x2, minus 3, x3, plus the input matrix. x1 dot is not a function of x1, 0. x2 dot is not a function of u, 0. x3 dot is a function of u, and the coefficient equals to 1, 1. The input matrix multiplied by u. This is the state equations x1 dot, x2 dot, x3 dot in a matrix form. X dot equals to ax plus bu. This is considered the state equation, the input matrix, the state matrix, 3 states, because we deal with a third order differential equations. The output equation can be found from the following equation: y equals to x1 multiplied by state variables x1, x2, x3, one x1 يبقى 1, 0 x2, 0 x3, b0 equals to 0 يبقى there is no this term. This is the solution of the required differential equation, which is considered a third order differential equations. This is the first information. The second data is the function doesn't involve, the input function doesn't involve a derivative terms. Thank you.